Welcome back, guys. Happy to help you. The second PU statistics subject. So we have a big chapter, so that is called theoretical distribution. So many students are asking me, sir, what need to study, what need not to study in theoretical distribution? Because we have 8 properties are there. So each property we have a 10. So we can't remember. So can you glance it or can you tell me the important question? So this type of question. So yesterday I got the from student side. So definitely, I'm starting now for discrete probability distribution. The first 4 discrete probability distribution. So one is called Bernoulli distribution, binomial distribution, and Poisson distribution, and hypergeometric distribution. So let me start. Features or property, both are same. So Bernoulli distribution. The first property, the Bernoulli distribution, the PMF. So P of x is equal to P to the power of x into Q to the power 1 minus x, where x follows range 0 and 1. So 0 is the probability of failure, 1 is the probability of success. And similarly, what are the range of Bernoulli distribution? 0 and 1, so very important. And what are the parameter of Bernoulli distribution? So that is P. Parameter of Bernoulli distribution is P. And what are the mean of binomial is P. So variance of binomial is PQ. Standard deviation of binomial is root of PQ. All 3 point is 1 under. It should be a 1 point. No need to say that, oh, mean is 1, variance is PQ. No. So all 3 sub point is equal to property number 4. Similarly, Bernoulli distribution relationship, mean is always greater than the variance. So these are the property. Bernoulli might 1 mark, 2 mark only they can ask you. And binomial, Poisson, hypergeometric. So it may be a definitely 5 mark question, 2 mark question, 1 mark question also. I repeat, Bernoulli distribution, PMF, P of x is equal to P to the power of x, Q to the power 1 minus x. And what are the range of Bernoulli? 0 and 1. The parameter of Bernoulli distribution is P, and the Bernoulli distribution mean is equal to P, variance is equal to PQ, and standard deviation is root of PQ. And the relationship between Bernoulli distribution is mean is greater than the variance. Here important is if they ask PMF also for 2 mark question, if they ask parameter also, range also, mean, variance, standard deviation, many times they ask relationship between mean is greater than the variance. So this is Bernoulli distribution. Similarly, binomial distribution. The second discrete probability distribution is nothing but binomial. So what type of properties are there? Yes. The first one. The PMF of binomial distribution is P of x is equal to NCx, so P to the power of x, Q to the power n minus x follows 0, 1, 2, etc. n. And after that, what are the parameter of Bernoulli binomial distribution? N and P. So many people have written NP, so you don't get marked. You have to write N and P. Similarly, the range of Bernoulli binomial distribution is x is equal to 0, 1, 2, etc. n. 0, 1, 2, etc. n. Okay. So after that, binomial distribution, mean is equal to NP. So variance is equal to NPQ. Standard deviation is equal to root of NPQ. So very important this. Even they can ask parameters are given to write down the PMF, and they calculate mean, variance, standard deviation also. And the relationship between mean and variance of binomial distribution, same thing for Bernoulli. Mean is greater than the variance. And when the mean and mode are equal. When mean and mode are equal, so that time NP is an integer. So this is the important 1 mark question. When mean and mode are equal, answer is simple, but NP is an integer. So these are the first 6 property of binomial distribution. So everything is important here. Okay, after that, a remaining property. 7, 8, 9, 10, 11. Okay. So here, 2 mark most important questions are available here. What type of question? 7th one you leave off, no problem. No need to worry for 7th one. We'll go 8th one. What is the 8th one? Number of time they can ask. Number of time they're asking already. So under what value of P binomial distribution is symmetrical? So P value is 0.5. Many times they're asking this. So that beta 1 is equal to 0. This also we can remember, beta 1 is equal to 0. So when under what value of P binomial distribution is positively skewed? Answer is P is less than 0.5. Under what value of P binomial distribution is negatively skewed? That is called P greater than 0.5. P greater than 0.5. So very important question. And 2 marks, the important is very important question. So this is 11th one and 12th one. What is the 11th one? How they ask. Under what condition binomial distribution tends to, under what condition binomial distribution tends to Poisson? So we have to write 3 conditions compulsorily. One is called n tends to infinity. Another one is called p tends to 0. Other one is called np is equal to lambda. We have a 3-point compulsory you have to write. What question? Under what condition binomial distribution tends to Poisson? Answer is n tends to infinity and p tends to 0 and np is equal to lambda. And the question number 12, last one. This is also important. So what is the question? Under what condition binomial distribution tends to normal? There tends to Poisson, here tends to normal. Based on this, so we have many questions are there. Yes, we are solving already 8 questions or 7 questions in the question bank. And the 12th one, only condition, no problem. So under what condition binomial distribution tends to normal distribution? That is when n tends to infinity, P and Q are almost equal. So this is binomial distribution. Properties are most important. We're able to clear the section A and section B also. Okay, next one. Poisson distribution. So what are the properties of Poisson? Yes, here also many properties are there. Yes, this is the properties are features of Poisson distribution. The first one, the PMF of Poisson distribution is P of x is equal to e to the power of minus lambda, lambda to the power of x by x factorial. X follows 0, 1 to infinity. I repeat PMF here. So P of x is equal to e to the power of minus lambda, lambda to the power of x divided by x factorial. X follows 0, 1 to etc. infinity. The Poisson distribution parameter lambda. Poisson distribution parameter lambda. What is the range of Poisson distribution? 0, 1 to etc. infinity. And similarly for the 4th one, important. In a Poisson distribution, mean is nothing but lambda, variance is nothing but lambda, standard deviation is root lambda. So very important. And while looking this, all mean is equal to lambda, variance is equal to lambda. Can it assume it? What are the relationship between mean and variance? Is obviously equal. So mean and the relationship between mean and variance of Poisson distribution is equal. So very important. The mean and variance of Poisson distribution is equal. This is 1 mark question. Bernoulli, binomial, both are same. Mean is greater than the variance. And similarly here Poisson is not greater than, because it's equal to, mean is equal to variance. Same formula. So because of that, so we are going to solve like this only. I mean, we are going to write it, mean is equal to variance. The next property after fifth one. So we have 10 properties are there, even sixth one also. When lambda is not an integer, Poisson distribution is unimodal, just like a lambda. And when lambda is, and the integer part of lambda is a unique model, that is only one. If lambda is not an integer, it should be unimodal, that is called lambda. If lambda is bimodal, lambda is integer, sorry. First one, lambda is not an integer, Poisson distribution is unimodal. Lambda is not integer, so definitely bimodals are there. That is lambda minus 1 and lambda. Definitely they can ask you guys, very important. So when, under what value of lambda, when lambda is an integer, definitely they can ask, lambda is not an integer, Poisson distribution is unimodal, the mode is lambda. When lambda is integer, Poisson distribution is bimodal. There is a two modes are there. One is called lambda minus 1 and one is called lambda. And even these important question, guys, this is under what are the value of beta 1 and beta 2 in Poisson distribution. Many times they're asking this question, especially. Poisson distribution is positively skewed, beta 1 greater than 0. Poisson distribution is leptocurtic, beta 2 greater than 0. Definitely they can ask 2 mark question. What is the value of beta 1 and beta 2 in Poisson distribution? So both are greater than, all of you remember, beta 1 is greater than 0, beta 2 is greater than 3. So very important. 10th one. So this is also 1 mark question. So under what condition Poisson distribution tends to normal distribution? Under what condition Poisson distribution tends to normal distribution? This is the important question, guys. So definitely, many times they ask this question also. Nobody answered. They're losing. Before is a 100-mark paper, no? So there is a 99 mark because of this question. Answer is lambda tends to infinity. Lambda is large. That also we can write. Lambda tends to infinity. No question, that is the problem. Only for theory part, you always remember. So when lambda tends to infinity or lambda is 0, when it is, Poisson distribution tends to normal. How many conditions are there? Could you remember? Binomial distribution tends to Poisson. Binomial distribution tends to normal. And here Poisson distribution tends to normal. Please remember these 3 points. I repeat, binomial distribution tends to Poisson, binomial distribution tends to normal, and third condition, Poisson distribution tends to normal when the lambda tends to infinity. Okay, after that, fourth one of discrete probability distribution. So that is called hypergeometric distribution. Here we have only 5 properties are there. So very simple. 5 properties of Poisson distribution, sorry, hypergeometric. So let me go that. The PMF of hypergeometric distribution, a very big one. So P of x is equal to ACX BC minus x divided by A plus B Cn. So x follows 0, 1, 2, etc. Minimum of A comma n. Look at that, range is very important in this, especially hypergeometric. The given parameter, you have to write range also they can ask you. Important one, because 0, 1 to minimum of A comma n. So that is most important for the range of hypergeometric distribution. And we have a sorry, we have a 3 parameter here, full of special. Everything we need to see, binomial is 1, binomial is 2, Bernoulli is 1, Poisson is 1, hypergeometric, we have a 3 parameter. 3 parameter if they're given order wise, first is A, second is B, and third is N. Please remember, A, B, and N are the 3 parameter of Bernoulli distribution. And finally, the range of hypergeometric distribution is 0, 1, 2, etc. Minimum of A, comma N. So this is important. So minimum of A, comma N. And after that, we have parameters also there. I mean, mean and variance. Yeah, good luck also there. Definitely, parameters are given to calculate mean and variance also. They can ask you many times. This is very easiest question because in Bernoulli, binomial, Poisson, and binomial tends to Poisson, these 3 distribution, continuously they can ask 2 questions there. So very easy to score it. And for a hypergeometric distribution, mean is equal to variance. Sorry, for hypergeometric distribution, the mean formula NA divided by A plus B. Remember, many people are writing NAB. No, NA divided by A plus B. And what is the variance formula? Big one. So NAB into A plus B minus N. Many people are writing minus 1 in the denominator. No, numerator is minus N, denominator is minus 1. And denominator A plus B the whole square into root of A plus B minus 1. Root of that will get variance only. So very important. The root of that, it should be a variance. So here also another 2 conditions are required. So what are the 2 conditions? Hypergeometric distribution tends to binomial. This is the 4th one. Hypergeometric distribution tends to binomial. When A plus B tends to infinity and A divided by A plus B is equal to P. This is under what condition? Hypergeometric distribution tends to binomial. So that is A plus B tends to infinity. A divided by A plus B is equal to P. And one more, binomial distribution limiting from hypergeometric distribution. So this is not tends to, just like in condition with parameter N and P. P is nothing but just A divided by A plus B. Look at that, guys. How many questions are there? Total binomial distribution tends to Poisson. Okay. Binomial distribution tends to Poisson. Binomial distribution tends to normal. Poisson distribution tends to normal. And even hypergeometric distribution tends to binomial. Please remember these 4. Definitely they can ask you 1-2 mark question for this year. So very, very important one. Guys, these are the properties of hypergeometric distribution. Remember mean and variance. So where is the wrong thing you have to do in the examination? You people are right, NAB. No, this is wrong. And here numerator NAB into A plus B minus 1. No, numerator is minus N first and minus 1 is the denominator. So all of you remember. So after that, many guys are not remember formula. So what type of formula there? The formula in the sense, so what is at least and what is utmost formula? Remember? So formula is, first formula, probability at least 1. Okay, probability at least 1. How to write? 1 minus probability x less than 1. That is equal to 1 minus probability x equal to 0, because range start from 0, 1, 2, etc. n. So less than 1, nothing but 1 number is already there. So don't skip 0. 0 is also one of the success rate, right? So sorry, failure. So that we are able to write x equal to 0. So similarly, probability of at least 2, that is equal to 1 minus probability x less than 2 that is equal to 1 minus probability x equal to 0 plus probability x equal to 1. So probability of one more, at least 3. So how to write? That is equal to 1 minus probability x less than 3. That is equal to 1 minus probability x equal to 0 plus probability x equal to 1 plus probability x equal to 2. Yes, this is at least one formula. Very simple. This is at least one. Okay. The next formula. So more than 1. So probability. So more than 1. That is equal to 1 minus probability x lesser than 1 is at least. Put it one line. That is more than 1 only. Therefore, 1 minus probability x equal to 0 plus even 1 also we have to consider. And similarly, probability more than 2. More than 2, that is 1 minus probability x lesser than or equal to 2. The 1 minus probability x equal to 0 plus probability x equal to 1 plus probability x equal to 2. Yes, similarly, probability more than 3. More than 3, that is equal to 1 minus probability x lesser than or equal to 3. 1 minus probability x equal to 0 plus probability x equal to 1 plus probability x equal to 2 plus probability x equal to 3. This is more than 3. The last formula, at most. Yes. So last formula is at most 1, 2, 3. So let's see how it is. The first one, probability at most 1. Okay, no 1 minus here, just probability x lesser than or equal to 1. That is equal to x equal to 0 plus x equal to 1. Similarly, probability at most 2 is equal to probability x lesser than or equal to 2. The probability x equal to 0 plus probability x equal to 1 plus probability x equal to 2. Probability at most 3. That is equal to probability x lesser than or equal to 3. The probability x equal to 0 plus probability x equal to 1 plus probability x equal to 2 plus probability x equal to 3. Remember how many formulas are there? You have to practice it. Otherwise, question number 27, 28, you can't answer. Seriously, can't answer. So many people are left theoretical and inference. They're able to concentrate, what is that, index number, intra, extra, and OR. But you left those chapter, you'll get only 4 questions. It's not happy for you people. So you should study at least theoretical. So that is okay for you. You have to write extra question. Correct, na? Right? So this is at least, at most, more than formula. So very important. And the next video, I'm able to do it for the 5-mark question. For binomial, I'm going to start, I will start binomial, then Poisson and hypergeometric, and binomial tends to Poisson. And one more thing, sir, everything is okay, but how to identify in the examination, binomial distribution tends to Poisson distribution. See, binomial distribution, very easy to remember. There is a p-value should be a no decimal, like this one, 0.5, so 40%, and 35%, and 65%. So all answer P, this is point after no decimal, so 0.4, so 0.35, and 0.65. Correct, na? Right? So this is the one hint, very easy to identify. Only binomial I'm talking, only binomial. Come to binomial distribution tends to Poisson, the very easy to identify in the examination hall. That is, p-value should be there is a decimal come, like 0.05. Look at that. After decimal, there is a one number should be present, that is 0.05, and p is equal to 0.01, and p is equal to 0.03. So look at the differences. Here, after point, there is no number, like 0.4, 0.5, 0.35, 0.65. Here, after decimal, there is a zero comes, like 0.05, 0.03, and 0.01. N should be a very large. N should be a very large. And similarly, n should be a very large. Finally, these two conditions are satisfied. So NP is equal to lambda. So that is also important. And finally, question number 25, index number. Question number 26, interpolation, extrapolation. Question number 27, 28, theoretical distribution. Question number 29, statistical inference. Question number 30, 31, OR. So first two, last two, many people know, but you should write extra question. So that is called question number 27, 28. So they're going to ask you binomial distribution, Poisson distribution, hypergeometric distribution, binomial distribution tends to Poisson distribution also. So you people are really concentrate. So this part. Binomial, Poisson, hypergeometric, binomial distribution tends to Poisson is completely question number 27, 28. So, okay, guys, thank you.